Okay, in Algebra 2, if you can't tell, I've been kind of doing a review chapter 1, review chapter 2. I'm going over some of the really basic information from that. So in chapter 4, I picked to do direct and inverse variation and then some domain and range, but I did simplify the domain and range, like I'm only doing the more common problems that you will see. So here I have the formulas for direct and indirect variation, and I'm just going to simply show you how to find the constant, and then I may give you an x. We'll decide when we get there and we'll figure out what y is. So here I know that y is 8 and x is 2, so I'm going to say 8 equals k times 2. So I can see this. I know 2 times 4 is 8, but I'm going to divide that out. So 8 divided by 2 equals k. And that tells me that 4 equals k. So in this case, if I were to say, well, x equals 3, what is y? I could set this up by saying y equals 4 times 3, which would give me y equals 12. Okay, so there we've got our two little answers. These are pretty quick, but they will come in handy with understanding a lot of stuff in science or in math from here on out, or just even some stuff that is said in some of the more complicated like literature classes. Okay, so inverse variation is a little different because it's set up as its inverse, so you've got a division in it. So we'll say y equals 1, we're trying to find k, but we know that x is 6. Well, I know 6 divided by 6 is 1, but I'm going to multiply both sides by 6. So that I can show you that 6 equals k. So here, if I were to tell you what happens when x equals, let's just say x equals 8, y equals what? So here I would set this up and I would say y equals 6 divided by 8. I'm going to simplify that down to y equals 3 over 4. So there you can see that I have my constant, and I also have my new y value. These kind of come in handy when you're graphing and when you're charting stuff. So actually they don't kind of, they do. It's good to know inverse versus direct. Okay, now with finding the domain and range, I put this here because even I like to double check with the chart. I do have it nearby. I'm pretty sure I understand this. So no, I'm kidding. I taught it to you. I know I understand it. So here we have what is known as, this one right here is a linear function. The reason for that is because it just has the one x in it. So it's got an x in it. Oops, sorry, my fan is going. It's got an x in it, it has a variable, but it only has the one of it. It's not squared, it's not cubed. So because of this, its domain is actually all numbers, all real numbers, but I'm just gonna put all numbers because I think you guys understand it and it needs to be real. With linear, since it's a line, so it would graph looking like this. This actually would because it's a positive slope. It's not just going to be all real numbers for the domain, it's also going to be all real numbers for the range. Okay? Now if we look over here, this is what is known as a constant. Because there is no variable with it, it's just a singular number. So for this, it's like saying y equals 12. And it's going to look like a horizontal line. So it's just a line that goes straight across through 12, okay? So because of that, its domain, which is from left to right, so the domain is the x values, it's still gonna be all real numbers. No matter what I put in for x, y is always gonna equal 12. On the flip side of that, its range, it's a horizontal line. It's not shifting up or down or anything. So its range is essentially always going to be, they write it as 12, 12 in square brackets. Okay, so that's how you would write that. Its range is, it's always gonna be 12. It has no other range. It's not gonna sometimes be 2. If y equals 12, it's always going to be 12. Okay, so for this, we have what is known as a rational function, because it is written as a fraction. So for this, the domain basically is the domain. So the domain again is the x values. So domain is all except for when x equals 0, because there's an x in the bottom. If it was just a whole number on the bottom, we wouldn't have to worry about that. But because it's got a variable down there, we have to say, we have to come over here and we have to do x minus 4 equals 0 plus 4 plus 4 x equals positive 4. So how we would write this is we would say, well, it can be anything from negative infinity to our x value. So 4, it can't include 4, but then it can also keep going from 4 into positive infinity. So what we have to do is, instead of saying that it includes all real numbers, we have to set this up to say, well, it can go to negative infinity and it can go to positive infinity, but it cannot be that number 4. There's no other real way to write this. And now the ratio is, or the range is very similar. So the range here, what we're going to do is we're going to say, okay, this is the leading variable. Okay, so my range starts at negative infinity, but it's only going to go up to the ratio of the leading coefficients. So my leading coefficients here are both just a singular x. My ratio of them is the fraction that they form. So in this case, 3/1, otherwise known as just simply 3. So I'll write that underneath it. And then it's very, very similar to the domain. It can't be 3/1, but it can go up to it and it can go past it. So it can be negative infinity up to 3, and then from 3 on to positive infinity. So that was just a quick review over direct and inverse variation and domain and range. Again, that chart is on page 186. You are going to need to know domain for rational. So you're going to need to know domain for rational, but make sure that you know some of the other stuff, because it may pop up if any of you guys decide to take your SATs this summer. So I will see you guys tomorrow. I'm not doing chapter 5 tomorrow. I'm going to kind of take a little break and go back and review something from chapter 1 that I wanted to cover in a whole lesson. So I will see you in that class tomorrow.